Okay, this is the moment the computer is trying to decide if it wants to work or not. So welcome. I was a part of, again, like CDFAM last year in New York. I delivered the opening talk, so I think I didn't do something terribly wrong. So I'm back here. One thing I realized here is that I saw all the presentations but one. It felt like CEFAM, E for engineering, a little bit. So I'm not an engineer. Actually, I dropped from electronic engineering, became an architect, became a footwear designer, I guess. I'm still kind of like exploring. So I'm going to put the CD back a little bit and bring things back home. And yesterday, there are a couple of questions about computational design. Just the facts, like, I'm indexing 0 is the first thing I want to talk about. Computational design is you are working on a design meaning, intentions, and knowledge, and you are trying to construct it through computational thinking, representing, sensing, and making. That's computational design. Okay? So this is defined by MIT Design and Computation Group, which I was a part of. I have both my master's and PhD from MIT in computational design. That's how I started. Interestingly, computational design, unlike what we think about it, it's more about humans than computers, because if you think you're different from computer, actually, you can use it to the max extent. Like, our brain has a way of working, which I'm going to talk about briefly, but then computers, they have their own way of working. So if you differentiate that, things get easier. My talk is all about that last year. Design, it's called Design Computation Human, if you want to check it out. So I had to put this slide this morning at 4 a.m. Everybody talked about heat exchangers. This is the biggest heat exchanger in town. So if you don't know, read about the history. Okay, so this building actually it uses the underground kind of tectonic plates, gaps, to chill and warm the building up in the winter and summer. So that's just a kind of a small note. So it's interesting. It also relates to what I'm saying is also actually a practice. I'm practicing it on my own. So when you're looking like this, you see that when you kind of you see Reichstag. Oh, it's okay, that's the heat exchanger. So it's really how do we kind of take our gaze away from the problems that we're dealing with, like computation, numbers, data, and then how can we come back to them and deliver the best we can. Being critical always counts. René Magritte, it's 1929, right? So it's the painting of a pipe, which is saying it's not a pipe underneath it. So the artist here is trying to tell us something. It's like I made a picture, which is not a photograph. It's a picture of a pipe, which is not a pipe. It's a picture. You figure out what it is, right? So that's the kind of the art, and it's kind of relevant because we talk about both generative systems, including AI and image making, but also making models is pretty kind of in a similar fashion as well. So this is my not a shoe. It's actually a photograph of a 3D printed shoe that was designed by using AI. The sole reason for this to exist is this. AI takes the image, kind of tools were kind of taken over, and I said, okay, let's make a shoe, let's put it on the table because somebody's going to step up and they're going to tell that, they made a shoe using AI. So let's do it. Let's keep it to ourselves. We did this. It's been 18 months. We never talked about it. We never showed it. And then, we employed, again, I'm not going to go into details, generative AI techniques. Image blending takes the image. But then, somebody takes this and employs some bitmap processing, modeling techniques. And then we finally made it's a Z-core print. So it's not a flexible model, which we had before for other ML models. But essentially, this is kind of showing exactly in the company, saying that AI is coming, it's okay. We made it, so it's done. And don't take it with grain of salt if anybody else does that. Okay, so that was the point. Now I'm showing it because it's done recently. Okay, so computational design at New Balance didn't exist. I started 8 years ago. I got the first title, and then I said we need a group. It was kind of constant value proof, preparing this proof of concepts and proving the value of computational design, why it's important, how can it help solve problems. And then, in my journey, actually, I built computational design teams for all these companies, Peterson Fox being the architecture, New Balance, 2 years ago, Samsung. And then I'm also often referred as troublemaker because instead of kind of like selling the stuff to you, I kind of like punch it in the face, like data and so on, computational design, and then show, okay, you know what, these are smart systems, but you have to be smarter to kind of like do something really about it. So this is my troublemaking slide, just to put everything into kind of like context. One thing really important for me is like, why are we doing something, and what is the added value? What kind of value are we adding? Are we doing it for like changing the world, like making it more sustainable, being remembered, and so on and so forth? So that's the kind of like what's going to happen with human population, okay? So at some point it ends. So just so you know. So the human population estimated peak is 11.2 billion people. We only have kind of like 76 years to get there, if my math is right now, right? And when you talk about AI, actually, AI started in the 40s. So it's been 84 years. So we are closer to our peak than the kind of like, like seminal work in AI. Just imagine that, okay? So then it's gonna kind of like start declining. And also the second note about troublemaking note is usually everybody gets forgotten by their grandchild have kids that like by third generation. Okay, so just keep in mind. So we have to enjoy, what we are doing a little bit. So this is not a plan. It's kind of it's the AI rendering of a plan that I draw like years ago, and this is not a facade. Same thing. What is interesting is like what's happening here. First, okay, why are we kind of like captivated with AI or numbers, data, which I'm going to talk about too? Because of this interesting kind of like transition, I wasn't doing any facade work here. Actually, I was trying to generate like plans, but because the data set is super biased towards, building facades, it kind of like started shifting towards that. And, we can talk about this, right? So is it interesting? Well, the transition kind of like looks interesting, so it was interesting for me for half a day. And from not a plan to not a facade is an interesting transition, so we get excited when we see that. But not everybody gets excited when they see that. Okay, so where is the distinction? Should we get excited or should we not get excited is the main question here. And let's ask why. So here's one. I'm talking about a model. The model motivates the architects to start working with realistic images at the very beginning of the design process. So this is kind of like proposing a rendering system which generates the images that you want to see. Sounds familiar? Have you seen any AI architects on LinkedIn? Making crazy buildings? Okay. So this is me in 2006. This is my thesis, which was, at MIT, trying to render the images that you wanted to see. Okay, so which was super challenging. I didn't know coding, so I had to teach myself coding first, bitmap processing, trying to numerically evaluate images and give fitness scores to them. I mean, I'm an architect, by the way. Like I wasn't a programmer at the time, so it was a big challenge of like learning. And then 5 years ago, I was like, oh my God, this is like machine learning, which I didn't realize at the time. So it was interesting. So when you do that, and this is not me, like I'm not talking about myself, I'm talking about experience of getting lost, which is probably happening to you too. When you look about generative design, it has I'm talking about specifically the image making tools. It has like a 2.5-year history, okay, on diffusion models and so on. I'm not talking about SCANs, which is older. Kyle Steinfeld, an older colleague, also a friend from MIT years, he wrote this, like, as I was looking, I found this article, which is super interesting, Clever Little Tricks. It's talking about the history of this image-making venture, which started in the 40s, and bringing it to this day. And what is interesting is that he published this by using references that are not scholarly, okay? So apparently he was taking a risk, but the article is kind of pretty strong. It says the connectionist AI in 40s used network to simulate intelligent behavior. So, then somebody's talking about a perceptron, a classification algorithm first invented in 1943. So those are the drawings of like neural networks from that time. It's the research. I cannot understand the math, so I'm not that kind of like deep. But if you look at the Warren McClough paper from 43, you're going to see that. So why are you maybe not also excited? You understand how things work. about like computationally defining aesthetics has been a problem since the initiation of computers. People try to kind of like find ways to make computers say what is good, what is bad. This is from George Steiner and James Gibbs, the founder of shape grammars. So this is the book from '78. There's a paper that's called AI and Aesthetics. It's called Architectural Intelligence and Aesthetics, right? So they are defining the system. So there's the initial conditions. There's a receptor, which kind of like sees stuff. And then there's a synthesis algorithm. And then there's an effector, which makes stuff in the environment, right? So they're kind of like hands and so on. 75. It's pretty impressive. He's also my kind of dissertation, PhD advisor. So it's talking about receptors. I'm going to skip just to save time. Are used for object recognition, right? And then effectors are used for physical outcomes. So one kind of like takes in, one kind of evaluates, the other one does, and so on and so forth. So these concepts have been there for a long time. But they end the paper saying the ability to specify criticism or a design algorithm. So the whole purpose is the system is supposed to make art or criticize art and so on. The ability to formalize a wide range of perceptual and cognitive skills and a wide range of knowledge, and thus can be extremely difficult to develop at the time. So that's what they're saying. So it's interesting. So those years, like 70s and 80s, like people start kind of like diverging to two parts. One is, one side follows digital, like computation as we know it. Shape grammars, for instance, kind of like steers away. So, at this point, Steiny and Gibbs, they say, we're going to talk about computation, but our bits will be shapes. So let's say x equal to 3, right, like a variable. So here you don't have symbols, like you don't have an x, you don't have, what you see is x is what you see. It's just like two squares, right? So if you start kind of like taking that shape, which is two squares or four triangles in this case, you have like two different descriptions for the same thing, which is computationally a challenge. But you can still define it, right? So if you have two descriptions for one thing, you can still, create these two states. But then you can also you can come from different sides and discretize it in this way, which is super weird. So two different things, you start discretizing and they become the same thing again when they're totally kind of like split. Like how would you make that work computationally? So these are kind of like incompatible descriptions of the same thing, which is a big challenge. And this is human vision. So that's really interesting because I'm not going to go into computer vision that much, but the way in which the computers see is not the way in which we kind of like cognitively see and understand things, right? So we had to kind of like solve it in another way. So let me keep discretizing these pieces into other parts. So I'm not going to talk about what they are, but depending on how you do things, you can get like different results, different, kind of like, let's say, number of different solutions. And then the problem is like, this is what we do. Right? Somebody comes to you and then as an artist draws a pipe or like an engineering problem appears which never existed, right? Like, so suddenly you have to kind of like solve for that, which is exactly the previous presentation that we just saw. So how do we deal with this inexhaustible problem? So one thing about AI, I'm going to talk about AI a little bit, is that there's this thing about HITL, right? Human in the loop. Anybody? Do you know that? Okay, somebody, that's great. So the promise is that AI does some stuff and it fails, which we saw, and then the human steps in and says, okay, it had to be this way. So you correct it and AI learns from you. Wonderful. And then there are papers about creativity. So one says the gold standard for creativity assessment is the consensual assessment technique. So we are going to get together and agree on something, in which human raters, us, meticulously evaluate ideas and products of the basis of their own judgment and expertise. So now we have to decide on this. I'm going to ask art or not, for instance, because we have a consensual census. It's art. I'm sorry, it's done. So you can't decide. It already happened in 1917, Duchamp, Fountain, it's art, right? So probably if this was a new piece, I was showing you this is my art piece, probably consensually you would tell me to get off the stage, and it keeps happening. Again, troublemaker humors, this is the Comedian, it's an art piece that was presented in 2016 in Miami Beach. It's called Comedian pretty much. So interestingly, again, you cannot compute these things. This is, it's the anomaly. It's kind of like outside the average, the statistical average. But you can computationally talk about them, like in mathematical terms. So one thing about shape grammars is that because I can take any shape, in this case I take the fountain as the shape, it goes to fountain. So that arrow is a computation, which means fountain goes to fountain and it's art. Or, you can get a banana and tape, which are like two different objects in two different layers, and you take the banana from the table, put it on the wall, so it's the T transformation of banana, and probably you squish the banana a little bit so banana get deformed, so it's like banana prime now. It's not the same banana you picked up, all right? And then you put the tape, which is the T of the tape, so that's the computation. That's how you compute art. And then somebody ate it. This is all real, by the way. It's not a joke. So banana goes to nothing is another computation. It disappears. And somebody already paid $120,000 for that artwork. So that goes to zero. Okay? So that's another computation. So what? So I showed this people, and people ask me, why are you still employed? It's not a joke. So let me try to kind of like bring it back. With Dawn, we did this interview just before I came. One question was, what have you explored since the last time? Well, AI, I looked into it. I didn't want to say AI. It wasn't interesting. And it wasn't really, internally it wasn't interesting either. What was interesting was the stuff that we were doing before that, like multi-objective, kind of like evolutionary algorithms. I happened to look into octopus, in this case, McNeil, rhino, grasshopper, thank you, again. And then, I called like Robert's name, I messaged them and so on. The wonderful thing about this is you're trying to optimize against two goals here, and there's a point that you can never achieve, which is wonderful, right? You're kind of like trying to get there, and again, never getting there. It's so real, it's like life. So we use these things to kind of like, of course, optimize things and digitally, but at the same time, you have to kind of like test the ideas physically so it makes sense. This is also all founded back in '75. So John Holland writes, about the multi-objective evolutionary algorithms in '75. So he draws this like pattern recognition device. Nobody reads it. Nobody. Like, they publish, and probably he was getting, he says, oh, and then in '92 he publishes a book, and in the book he says, well, every year we were selling like 100 copies, maybe 200 copies of the book. Check the citation number. And that's only the '92 paper, not including the previous one. So he got, I think, 40 to 70,000 citations for that work. So it was a little bit early. So this is the so what problem, the so what kind of like problem. At the time, if we are kind of like converging towards the same thing together, probably most of us are going to fail. It's not interesting. Okay. So if you're trying to kind of like steer away from the crowd and if you're wrong constantly, I would still, suggest going that direction. There might be something there if you're internally feeling, there might be an answer elsewhere. So starting early is good. It's kind of like painful you're alone there. So generative components, who knows about generative components? There's one person there raising his hand. I'm gonna tell who you are. So this was like 2004 and 5, and constantly we were saying, this is MicroStation from UK. We were saying, the symbolic view, we want to pull wires and plug them. That's how we want to design. That was the feedback we were giving. And they're like, no, it's representation. Like you have to, it's hard to do. And then, what happened, right? Grasshopper came in like 2007. So that was it. So we were like, okay, we were talking about this. So 2006, I started doing, these. This was a building that I had to reconstruct from the points because it was parametrically designed and the model was corrupt, and I was hired. So they asked me to rebuild the building from points. Then I had to learn Rhino Visual Basic. So that was pretty much it. This is a drawing by Bradley Rothenberg, of the CEO of Anthropology, because he was a curious student, and I got a chance to kind of be his mentor while teaching generative components. So this was the kind of architecture he was doing as a student. Then he said, I'm going to become a CEO, I guess. So that's good. We had access as KPF to object machines, 3D printers, Z-Corp really early. When I look back, we were kind of like redesigning all the structures for printability, and we were challenging the tolerance of the machines at the time. So, like just looking back, we were designing for actually like the manufacturer. They're not mechanical parts, so I don't want to I don't want to demean the crazy complexity that you're dealing with. I'm just saying, like, there's a portion of computational design architects that dealt with these problems without knowing what they were doing, which was the interesting part, I guess. Built intelligent systems. So there's a red dot circle there. It's a self-aware facade system. If it ends up generating the same pattern, it kills itself and regenerates pattern again. So those are the kind of like stuff that we were doing. And for TPMS and lattices, so when I joined New Balance in 16, but they were doing already, like lattices. And by 2020, we were already done. So we were kind of like, so when I designed this, I knew that it was printable with the material. I kind of more or less know the, let's say, physical properties and the feel, which just came by experience, right? So I just want to highlight that. Again, it's not about me. Because we ended up printing 1,300 parts, we got a kind of like mental sensation of how the thing works with that resin, with that printing method, and with the, kind of like the lattices we had. So if I had, like, if we try to train AI today, probably we won't be able to because we don't have enough data to kind of like get that insight, which is an interesting problem. Before AI, there was ML. You remember that, right? Machine learning. It's interestingly, I'm not talking about us again. Maybe in general public, the technology comes, it becomes a kind of like super hype, and then it kind of disappears, right? So everybody was talking about machine learning, scans, and so on, and then now everything is AI. A couple of people said machine learning, so thank you for that. One is an umbrella term, obviously, everybody knows that, but it's how what is interesting is that the way we talk about things also changes the way we think about them, obviously. ChatGPT, right? The way you described it. It tries to think, but it can't. So one thing we were doing is kind of like blending these image methods and, from like GANs and then trying to blend it with pressure data and so on and so forth. So one thing I do is I create some other problems before I solve all of them. So one was, for instance, I was really not super happy with the way pressure data was being kind of like represented, right? So at some point I said, okay, just see which is the conventional way is what you're seeing there, right? Usually kind of flat ground, but this is not 100% real. It's kind of like all the data streams are coming from elsewhere. The moving foot is an interpolation, outsole and an insole doesn't belong to that scan and so on. But this was my proof of concept of kind of like showing, hey, we can look at this problem in a different way. Not only talk about what's happening under the foot, but in and up towards the foot, and then maybe think about like the ligaments, muscles, and so on and so forth there, right? And then you can also deal with the what's happening outside. And we were talking about like VR at the time, so I kind of like blend all these together. When I saw Moon Rabbit's presentation yesterday, that's one of the ones I really love, because I haven't seen anything close to kind of representing data in 3D that way, so congrats for that, which made me put this, so that's good. The next thing, and also like when I deal with this, one thing I started going to, so I was hired to work on data to design streams for New Balance, and the first thing I said, there's no data anywhere, right? So that was one of the things I said. And that is to say, again, just making us aware that it's not like there's a data and we get collected, it's we project it, right? So this is pretty kind of like Albertine way of, you don't set a frame and see the world, actually, you project from your eyes. I want to see data under your foot or on the building so I can make sense of it, and computationally I can work on that, right? So these are kind of like great questions. This was a question, again, like, how can you bring art and architecture and footwear design and so on, so together, and, again, like referring back to my, how do you convert this to capital was a question. And well, I like being on the critical side because hopefully you're getting something from this, questions. I want you to leave with questions, right? So that's my only goal here. So just to demonstrate that what we did was, this is a 6-meter wide, 2-meter high mural that is kind of like plastered at our innovation corner now at New Balance. So I kind of like pushed for this to be designed. Where is Math? So Math wrote the code for this. Just for generating this mural. So you kind of put the image, you dump images, you dump the shape, and just generate this 600 DPI printable 10-meter mural. So if you need anything like that, we can help with it. Just to show that, hey, this is the breadth of things you can do. How can we make meaning by using that? One thing I'm trying to say is, I'm coming to the end, so I'm not going to hold you too much. I'm almost there. computation, engineering, efficiency, like making everything efficient, making everything data agnostic, making everything with the rules of the fragmented world. If we are kind of like feeling meanings are, getting lost as we compute things or compete with others, right? You're kind of like losing quite a bit there. So it's always great to step back and say, hey, I want to use computation and I want to compete with people. How can I preserve those meanings? I think that's very important. One way to kind of like, if you know what you're dealing with, that helps. The yellowish books are two good books that I suggested in my interview, which are about computation. George Dyson, Turing's Cathedral, and What Computers Still Cannot Do by Hubert Dreyfus. Those are wonderful. And the other two books are really useful. The bluish ones are useful for understanding of meaning and information. Like what is meaning, what is information, how they differ, and how can you, again, learn about those and bring it back to computation. I found them pretty useful. If that's too much, I prepared these little pills and wrote about them. So this is my Medium account. You can find me on Medium. Everything framed here is about AI, information processing model of the mind, how human brain works, how creativity works, how this connects to computation, and so on and so forth. So I keep writing. Also, it's my journey of like finding answers and getting lost again. One thing about AI is that the problem is generic tools, methods, or thinking won't yield good design. So that's one of the, again, suggestions maybe I'm making. You may agree or disagree. Or if you're looking for an average solution or close to the edge solution, good enough solution, maybe that's good enough. But like some people like shooting for that red dot, which is elsewhere, right? And the problem is almost all AI applications are generic, like because it's a statistical kind of like average of what you can do with that. And I was super excited when I read Professor Sigmund's interview, because he mentions about extrapolation and how AI is really limited in extrapolating data. I was like, okay, like an engineer is saying what I'm saying as well, so I should use that for myself. So thank you. So the goal is the red dot. The tool is AI. I'm wishing you good luck. All right, so that's pretty much that. I don't think you can land there. You can, but just using AI as a tool, with all the other weapons you have. Also, one thing is, when we do, computation, again, like when we talk about efficiency and so on, we get lost so much in the colorful pictures and details and how good the systems work, we negate ourselves. Like, stop doing it, right? So, like, talk about the tools and, let's say, processes, numbers, data. But I think the insight and input matters so much that there's learning that we have to kind of like, do by hearing from other people. So I was writing, some of this is becoming a chapter in a book. And then I was writing about this, and I'm like, I have to highlight the human in the loop. Like, that's like, I started reading papers about it because the human steps in and, tells AI, this is the right way to do it. And then I was diagramming it out. It didn't really work. I'm like, no, this is wrong. Human is the loop. It's like there is no human in the loop. Like, there are no loops without humans. I mean, you are the loop, right? So even when you're training an AI, I had to write this. I was like, okay, human is the loop. When you're training AI, there are no loops that humans are not a part of. Like, if I cannot think about a loop, then it's not mine. I'm not the. It's that's solved. So any loop that I can think of, I think we're a part of. And the other thing is, to all your credit, again, like this was super inspiring for me. Thank you very much. Again, I saw all the presentations but one. Unfortunately, it was, I was mind blown. You have already imagined or engineered what is attributed to AI today. This is externally happening in generative AI for language models, for image to 3D, which has come. I'm going to talk about that later. Not today. Don't worry about it. This is the last slide. I'm done. Not today. But again, give credit to yourself and just embrace AI as just another tool. So this was, for instance, just modeled and rendered. Now AI is creating this kind of stuff, and everyone, oh my God, have you seen Midjourney? Yes. Just to highlight that, this is the last slide, last animation. How you communicate this at a company like New Balance, 10,000 people now, is very important. AI. And I happen to be, like everybody comes, okay, you are the AI guy. I'm like, I'm not the AI guy. I'm a computational designer. So, okay, it's close enough, right? So you have to do something about it. Okay, I'm sure. So it was more like picking the right tool, which is an AI rendering tool that uses designer's sketch. So instead of, it also use prompts, right? So you can use all this like text to image, real-time rendering almost, but at the same time, it's very embodied, right? So like the designer doesn't have to change. Now I have to describe it with words. Like it doesn't work, right? So how you retain that and also use this tool. So what we did is we made people, non-designers, submit sketches. So we asked all the non-designers to submit sketches, pick one, and then I spent a day making this video, also just rendering, interpreting that sketch as a design, and just we gave that video back to those people. I'm just going to leave you with that, and thank you in advance. Let me get the sound right. Sound is. Oh, okay. All right. I'll just open it here. Thank you.